Morning, hello. Thanks for being here. Let's talk about mkosi-initrd enablement on openSUSE Tumbleweed. My main goal here is to show you why I think this is an interesting approach and show you how it works, some details, some useful data, so you can draw your own conclusions about this. Starting, Antonio Alvarez Feijoo. I work at SUSE, the System Boot and Init team, and I mainly work maintaining dracut and, to a lesser extent, helping with systemd. So, I assume that you already know what an initrd is if you are here, so I will be very quick. The initrd takes part in the boot process between the kernel and the host system manager. The goal is to find and mount the real rootfs, which can be on a local device, over the network, with a fancy layout like RAID, LVM, etc. And once found and mounted, perform a switch root operation and execute rootfs in the process. It is loaded into memory by the bootloader, mounted by the kernel as in memory file system. It's composed of a set of one or more CPU archives, and it is optional, and it can be compressed. So, a little bit of history about this in openSUSE. The host system manager is systemd since November 2011. And the initrd generator, by default, is dracut since November 2014, which is 3 years later. But the first upstream release of dracut was 1 year before the first upstream release of systemd. And the first upstream release of dracut supporting systemd was 2 years after. So, as you can guess, dracut is not optimized for systemd. It contains a lot of code, which is it runs every time the system boots. That doesn't have to do anything when systemd is around. Anyway, dracut is not only our default initrd generator, but also the most widely used by other distributions. It is composed of a set of bash scripts and a C binary helper. And it builds initrd images by picking files from the host system, and it adds custom logic to the boot process, using 10 systemd services as a means, plus two more systemd services that take part in xrd. It adds hooks, which are ways to inject scripts at boot at some point. Breakpoints extend the kernel command line via etc. The init queue, which is a blocking loop, checking that all the necessary hardware is being discovered. And mkosi-initrd can be considered another initrd generator. But the way it works is different. I mean, it is a wrapper on top of mkosi, which in turn is an OS image builder. And specifically is the image builder created by systemd. They have the same upstream. So it is the image builder that best integrates with systemd. It is written in Python, and to build the initrd images, it uses distribution packages and package managers. In our case, RPM and zipper, but in other distributions, whatever they use. So the main goal is to be as dumb as possible. I mean, if some specific functionality has to be implemented, it must be elsewhere on any specific package, not in mkosi-initrd. So there is no extension of the kernel command line via etc. That only works with dracut. In fact, right now, the systemd units and generators ignore this extension made by dracut. So there is not alternative real. I mean, maybe using temporary files, but not extending the current command line. There is no hooks, but this functionality can be implemented using systemd units and generators. And there is no init queue, so you have to subscribe to that events to be notified as every new hardware is being discovered. And there is no exitRD, but this can be more or less done with systemd shutdown, because systemd shutdown allows to execute some scripts at shutdown as a cleanup. In fact, MDADM is doing already this. So how can we specify what we want in the initrd image created using mkosi-initrd? Mostly using configuration. It is composed of init configuration files with drop-ins allowed, systemd style, custom file system trees, and build scripts at different points, but most of them are not necessary. So what do we have out of the box? Lax decryption. And using profiles. Profiles is a new feature currently in JIT main. And it's like, intends to be more or less like dracut modules. I mean, it's a predefined configuration set, which under a certain name provides a certain functionality. Upstream, we have right now LVM, RAIN, Plymouth, and networking using the systemd stack and NFS, using NFS root BNFS before only for now. The two last profiles are being developed right now. And using custom configuration, we have networking using network manager, iSCSI as a proof of concept, and whatever you can think of. I haven't found any technology blockers yet. So let's start with an example with the network manager. The configuration consists of, under etc, we have two site directories, mkosi.conf.t, with a drop-in to configure what we want to install there, and mkosi.extra to add a custom file system tree, where we can add some custom files to the image. So the configuration drop-in contains what packages we want to install there, specifically network manager. If we want more binaries, for example, ping, IP for debugging, we have to install the packages that contains them. The systemd system preset file to actually enable the services in the initrd, and a custom configuration for network manager to not create wired default connections in the initrd by default. And that's it. I mean, we don't need to write any code or to do anything else. I mean, it's so clear. Another example, for example, how to translate an existing dracut module into something more abstract that can be executed via mkosi-initrd. I chose dracut PCR signature. This is an excerpt of the spec file. It contains a systemd generator, this putfi generator.sh, systemd service, this PCR signature.service, and the binary, the script, it executes, the service executes when it runs, which is this PCR signature.sh. And everything is installed within the dracut module. A more generic approach. I would rename the dracut PCR signature module to initrd PCR signature. And the files would be installed in standard and well-known places in the system. So the systemd generator, the service, and the script that executes will be in the whole system. And I would create two systemd, two subpackages, one for the dracut module and other for the mkosi-initrd configuration. This is the current content of the module setup script. It installs some kernel modules, pfat, and some NLS, some of the NLS. It installs ddntr. It also installs the scripts it is providing, and it enables the systemd service in the initrd. And this would be the generic approach for only changing the lines in green. Now the files are in common places on the system. And this is the mkosi-initrd configuration. Installing the mkosi-initrd subpackage, installing the same kernel modules as before, and a systemd system preset file to enable this service in the initrd. Again, it's very clear. You don't need to write any bash code. You don't need to understand the specific format of the dracut modules, and it's pretty standard. Some loosing ends. ddntr. So the way to install binaries using mkosi-initrd is via RPM dependencies. So the subpackage needs to require core utils. And the generator and the service now are on common places on the system. So we want those to run only initrd. For that, we need to check the presence of the etc initrd release file. So how to enable this in openSUSE Tumbleweed? We have a variable called initrd_generator. You can set this in etc/sysconfig loader and just install the package. Also recommended enable package caching because we are installing packages. That takes time. And if they are on the system, you don't have to download them. You just use what you already downloaded before. But we will see some things about that later. What we have done upstream so far? Optimization fixes for openSUSE zipper, handling input devices, integration with SUSE module tools, movement and UDEP root, MDADM, breakpoints in systemd, networking support in Network Manager, rootfs over NFS before in NFS utils, some profiles for mkosi-initrd, and support for kernel module packages. As you can see, it's working in different projects, and trying to move things out of dracut. Next, if there is interest, of course, would be the integration with transactional update and SDBoot util. I mean, the integration with transactional updates would be easy, and the integration with SDBoot util would be more challenging because now there are some new dracut modules provided to support full trace encryption, but it is doable. So I will show you some test comparisons with dracut. For that, I use these four test systems. The first one is an old laptop from 2016 with NVIDIA card. And the next are KVM machines, one with an LVM layout, other with RAID 1, another with LVM on top of RAID 1. And I want to compare initrd size, the build time, and the system boot time. So the size. As you can see, compared with dracut, can be the double, a bit more. You can think that is a lot, but we have been working with configuration shipped by the distro to remove from packages things that we don't need there. So it has a way to improve, but yeah, it is where it is. Number of kernel modules. A lot of kernel modules on my laptop because of the media drivers. No, sorry, but not so much. There are more kernel modules installed with dracut than with mkosi-initrd, because dracut, with every dracut module, installs a set of kernel modules that sometimes are not necessary. And mkosi-initrd has a small set of kernel modules that are always installed, and then installs all the kernel modules loaded on the system. Firmware. Yes, that's what I meant before. On my laptop, having NVIDIA drivers, I have a lot of firmware files there. And why is it different from dracut from mkosi-initrd? Dracut is using the C binary helper with calling lickmod to resolve dependencies. And mkosi-initrd calls directly modinfo. So one of these two tools has some flaws. I don't know which one. So this is a summary of what we already said. Dracut picks host files, and mkosi-initrd stores packages. mkosi-initrd adds all loaded kernel modules from the system, and the difference between the binary helper and calling directly modinfo. The build time. I only choose one of the virtual machines because the percentage of time spent in every section is similar. Dracut takes roughly 3.5 seconds, while mkosi-initrd, if it has to download the packages, and I'm showing numbers under my specific internet connection at home, takes more or less 1 minute, and if the packages are cached, approximately 10 seconds. And this is digging into where mkosi-initrd spends its time. So the first and fourth columns are seconds, and the second and fifth are the percentage of completion. So the first big jump is the zipper call with 3.5 seconds. And the other parts having some time are related with the kernel, applying kernel module filters, running modinfo to fetch kernel module dependencies, and calculating required kernel modules and firmware. And that's at like 3.2 seconds. The other parts are roughly 3 seconds. So downloading and installing 100 packages take time. Caching RPM files helps. And the bottlenecks, external zipper and modinfo, internal, some parts related with kernel modules. The boot time. For this, I rebooted the system between 300 to 400 times, reaching multi-user target or graphical target on my laptop, and just taking the values from system deanalyze time, specifically the value of the initrd and the value of user space, because I wanted to check if there is some kind of improvement starting some services early in the initrd. And the legend is the test system, the percentage of improvement compared to dracut, and the time spent using dracut and its standard deviation, and the same for mkosi. The standard deviation is a measure of variability. I mean, it compares how much is dispersed the sample regarding to the mean. And the lower the value, the more predictable the result. So the first one, my laptop, improves from 4.3 seconds to 3.7 seconds, probably, which is approximately 700 milliseconds. Yeah. And okay, maybe it's not too much because the complete boot time takes 20 seconds on my laptop. And the reason of improvement is we are avoiding 1016 services from the unit file hierarchy that dracut always has. And the measure for user space, very similar, nothing to say here. With LVM, so dracut takes 1.8 seconds in the initrd, while mkosi-initrd takes 1.3 seconds. That is an improvement of 500 milliseconds. Yeah, as you can see, some variability in dracut. And the reason is, with dracut, it has a custom implementation for LVM. And mkosi-initrd just installs the LVM package, and the system service starts early. And user space, very similar, nothing to say here. With rate, also a big improvement. From 2.2 to 1.3 seconds, that is 900 milliseconds. And the dracut sample varies a lot. And also in user space, we improved from 2.8 to 2.0, which is, if you add to the previous 900 milliseconds, we have now 1.7 seconds less. And I forgot to say that in this virtual machine, the complete boot time takes 6 seconds. So this improvement is quite noticeable. And LVM on top of rate, again, you can see a big improvement from 2.5 to 1.3, which is 1.2 seconds. And user space, very similar, nothing to say. So conclusions, pros, it's a faster boot, it's less complex, we have a clear ownership of packs. Any change on a package will automatically apply to the initrd. So no more systems breakout boot that are not included in this required binary or library by systemd. And it shifts the maintenance effort from dracut to the responsible package. But that would be in an ideal world. Cons, slower build, larger size, limited R support, x64 and ARC64. Fragile to packaging errors. If an error, a package introduces a build error, it can break the build of the initrd. On the other hand, it should be taken before in OpenQA. And it takes longer to implement features because there are hard dependencies of dracut everywhere. Some upstreams can say dracut is handling this, right? We are going to take care of it. Or we want to install these new upstream services until dracut support them. I mean, dracut is a hodgepodge where almost everything is allowed. So it is very difficult to convince people to stop using it. So final, in my view, it's good for users. It's a valid alternative with pros and cons. It's good for openSUSE because it leads to improved packaging. It's good for dracut because we started to remove and adapt custom functionality to the new upstream functionality. And it's good for upstreams because now can control their functionality without someone in the middle. Some references, and that's mostly it. I don't know if we have time. No, we don't have time for questions. So.